There you go, guys. Just wanted to run through 2008 HSC question 10. This thing here. It was find the area underneath the curve y equals the natural log of x minus 2. Fuck off this one. That comes in later. Anyway, between 3 and 7. The 2-unit way is you take the e of this function and you switch your limit between 0 and log 5 and you find this shit here and you minus from the rectangle, which is good enough, and then you find this. Because in 2-unit you can't integrate a log. Me being the fucking poofter that I am, hated doing that, so I taught myself how to integrate a log. So I'm gonna run through how to do the 4-unit, 3-unit method, whatever it is. Please don't kill me, Dega, SamQ, all you guys if I fuck up. But yeah, this is for you, Grant, because we were talking about this the other day. So the law states if I have the integral of u dv, that equals u times v minus the integral of v du. Alright, so what all of this shit means, that's just the law. But what this means is our function here, u times dv, is what we have up here. Now I know what you're thinking, like what's u, what's dv, what the fuck's going on? You can substitute this whole thing for u. So u equals the natural log of x minus 2. But then, what's your dv? Well, if I times this whole function by 1, it's the same. So your dv will be just 1. So dv equals 1. So you got your u. To get your du, obviously you derive it. So du equals the differential over the normal. Easy enough, 1 over x minus 2. And to get your v, you integrate dv. So if you integrate 1, you just obviously get x. So there you have your u, your dv, your du, and your v. All the things that you need to plug into your formula. So basically, when we plug this in, we'll do it up here because I'm running out of room. U equals the log, sorry, where is this? The log of e x minus 2 times your v, which is x. Just trying to show you. Sorry, this film is kind of bodge. Minus the integral of v, which again is x, and your du times your du, which is 1 over x minus 2, all with respect to x. So you got your thing here. You can not simplify, but like, I don't know, whatever, fucking simplify it out. If you simplify the left bit, left hand side, you just get x log e to the x minus 2 minus the integral of x over x minus 2, or with respect to x. Now this just stays, doesn't change, doesn't move. Yeah, this on the other hand is the tricky part. Now the first time I did this, I fucked up. I didn't realise that you had to divide a polynomial, which is a 3-unit method. So if we divide a polynomial, the way we do it is you take whatever's on the bottom, so in this case it's x minus 2, and you divide that, sorry that's a square root, let's just pretend it's a divide. You divide that with whatever's on the top. In fact, let me just fuck that off, whatever's on the top. So the way you do this, guys that know how to do it, whatever, just bear with me for a second. This is a really easy one, let's just run through it. You look at your first value on the outside, and you have to realize, or you have to figure out, what do I do to x to get x? Well, in this case it's really fucking easy. You just times it by 1. So that's how you get your 1. So then you distribute whatever you times, all on the outside. So 1 times x is x, and 1 times negative 2 is negative 2. So you put all this in brackets and you minus it from the x. So x minus x is obviously just 0, and minus 2 gives us plus 2. This is our remainder. Alright, bear with me for a second. So, the way we can rewrite this, in fact we'll do it down here. X on x minus 2 can be rewritten as whatever you had as your on the top of your division. In this case, it's like, this is probably the easiest example you could ever get, but it's just the way you gotta do it anyway. So you get 1 minus whatever your remainder is over whatever was outside. So in this case, it's 2 on, x minus 2. So that's just a nifty little way you can rewrite that integral for the second part. So if you plug that back into there, it just becomes a hell of a lot easier, because then we'll get your proper integration. So if I just grab my little duster master, fuck that off, and then, sorry guys, so then we'll rewrite this bad boy as x log base e of x minus 2 minus the integral of 1 minus 2 on x minus 2 dx, because that's what we just proved before. So rewrite this line again because you can't really do fucking anything. X minus 2, integrate 1, you get x. You realize that this is a log, so what do I have to do to log to make it equal this shit? Obviously, if you know 2 unit, it's 2 times the natural log of x minus 2. I'm not going to explain how that is. If you don't know it, fuck, go research it. And there you have your integral. That's basically it. Then you just plug it between 3 and 7. I'm going to expand this out really quickly. So we'll get 7 log 7 minus 2 is 5 minus 7, just plug in your 7, minus 2 natural log of 7 minus 2 is 5. So all this is minused from, now if I if I plug in 3 times the log of 3 minus 2, 3 minus 2 is 1, so 3 times the log of 1 is 0. This is 0. Sorry. Minus 3, just plug it in. Minus, again, 3 times 2 is 0, 2 times the log of 1. 3 times 2 is 1, what am I saying, fuck. Yeah, it's fucking 0, whatever. So if I distribute negatives properly, this is what fucks people up if you don't distribute negatives. Let's just simplify this out in one big step. So 7 log 5 minus 2 log 5 is 5 natural log of 5 minus 7 plus 3, because you distribute negatives, is minus 4. And this is all just units squared, because the question asked us to leave it in exact value. So that's basically it. You can do the 2-unit method. It's probably a lot easier, but I'm just a HK and don't fucking like 2-unit. So just it's not that hard. You just learn your integration by parts. This is an easy one. Just don't forget how to divide polynomials, which is a 3-unit thing. I rubbed it out, sorry, but you end up getting that. I think the thing that's gonna fuck you up is distribution of negatives and positives. It's something so simple, but it's something that a lot of people fuck up. So that is your answer in exact units, and that's basically it. This was for you, Grant, because we were talking about this the other day. Anybody who wants to call me faggot, I honestly don't give a fuck. Until you can do this, like, just shut the fuck up and go back to school and do something with your life, rather than sucking your own dick. Thank you.